Hi all. So in this video, we'll be seeing about the mapping of various signals in various AMBA protocols, namely the AXI ACE AHB APB, and how they are different signals can be mapped to each other. So let us start with the address and control phase. So in the address phase, we have the EW address or ER address. So in the ACE, it is the same. So in case of ACE, most of the signals are same as the AXI protocol, apart from additional coherency based signals. And HP it is H address and EPB it is P address. So in case of the AXI, we have a separate read or write for the AXI or ACE, but in case of the AHP and EPB, we don't have a separate read and write. Instead, we kind of have some signal called P write or H write, which kind of tells you whether it's a write or a read. The transfer type AW valid and AR valid. So this is for the valid. In case of AHB, we have something called the H trans, which is used instead. And in case of APB, we have the P select and P enable for the same. In case of the ready, we have the AWR ready and AW ready and the AR ready. In case of HP and APB2, we have the H ready and P ready. And yeah. And next coming to the length, burst length, we have the AW length and AR length. In case of AHP, the length is a kind of is within the info is present within the express signal itself. So APB only supports single transfers, so we do not have any burst transfers here as an APB protocol. Next, coming to the burst type, we have the AW burst and AR burst. So in case of AHB, we have the H burst. There is no burst, there is no signal here. And transfer size is AW size or AR size. So here we have the H size. APB fixed by BuzzFeed, so we cannot actually change the size of the APB transfer. Log, we have the AW log and AR log here, and we have the H log here. There's no exclusive no, or locked access in case of APB protocol. For the protection, we have the AW prot and AR prot. So this is kind of, we have the H prot here, and we have the P prot for the APB protocol. And for the cache hymns, we have the AW cache and AR cache. And some signal bits of the HPROT itself kind of is used for cacheable and bufferable info for the HP, but not very exhaustive here. And in case of APP, we do not have any kind of cache support here. That was for the address and control phase mapping. So moving on to the right data channel mapping. For the right data, we have the W data here. And this we have the we just have the H data here and HW data and P write data here. But in case of the AXI, we have a separate channel. So write valid is W valid. So here we actually make the H write to 1 for a write transfer and 0 for a retransfer. So H write and H transfer combined together is used for a write valid, and P write is for the APB protocol. And write ready is we have the W ready here and H ready here, and P ready in case of APB. For the write strobe, we have the W strobe here, and in case of the APB, we have the P strobe. In case of AHB, we do not have this byte enable support here. And to indicate the last beat of the transfer, we have the W last here. But in case of AHB and APB, we do not have any signal to indicate the same. So in case of a read data channel mapping, for the read data, we have the R data here, and ASB HR data and PR data separate channels. So in case of XI, the R valid here for the valid signal, and in case of the no, the AHP and the ABB, it is actually a case of typo here. We make use of the same H write transit, H write and H trans for these as well. So let me just H write and H trans is used here, and here we make use of the P write. And R ready here, the ready signal, we have the H ready and the P ready here. And for R last, for the last bit of the transfer, in case of AHB and APB, we do not have the same. So coming to the response or status channel, for the right response, we have the B resp here, and in case of H resp, and in case of APB, we have the P slave error kind of signal. And read response, we have the R resp, and in case of AHB, we have the H resp here. The same HRSP is used for that, and APB we have the P slave error. In case of AXI, we have the P valid for the response valid, and so here actually again we do not have any kind of separate response valid kind of a signal in case of the HV and APB. So moving on to the ID and ordering and currency aspects. So transaction ID, so we have the AW ID and AR ID here. So in case of HPAPP, we do not have any kind of ID supports here. So here we have the R ID and B ID as well for the read and write ID. We do not have any such support for the HP and APP. Coming to the Snoop address, right? So we have the AC address signal in case of the ACE protocol, and Snoop response, you have the CR response. So this is only supported in the ACE protocols. And when it comes to clock and reset, so those are pretty much the same in all the cases here. A clock, H clock, and P clock, and A reset, H reset, and P reset. So this is about the mapping of various signals and across different protocols. Thank you.